Okay, I'm going to go a little quicker on these next ones. 44, when iron rusts, it goes to reaction with oxygen to form iron 3 oxide. And you have 4 iron, 3 oxygen, 2 iron 3 oxide. And you have 52 grams of iron, and we want to know how many liters of oxygen. So that is grams to moles to volume. So am I at STP? Well, if you take, by the way, grams to moles, you could do 22.4 liters at STP and get that answer. Or you can stop at moles, put in here, and put in 273 for temperature and 760 for pressure, or 1 atmosphere for pressure, or whatever the other one is, 101,325 pascals for pressure, and convert with R. I'm not sure how I did this one. It looks like I did the 22.4 thing. So grams Fe to moles Fe to moles of oxygen to liters of oxygen and 22.4. This cancels here, this cancels here, this cancels here. You multiply all that through, you get 15.6. You shouldn't have any trouble with that. Okay, on the next one, I stopped with moles of B and used PV equals nRT. Now I haven't read this problem. If I've read this problem, it could be that you end up at non-standard conditions. There's 2 ways to get there. You could go all the way down here using 22.4, and then you can use the combined gas law to carry it to convert it to not standard conditions. A quicker, easier way to do it is stop at moles and then use PV equals nRT to get to your non-standard conditions. Okay, during the reaction, the gas cools to 20 degrees Celsius. That's not 0 Celsius. So we are at 20 degrees Celsius is 293. So PV equals nRT is going to be the way to go. And 1 atmosphere of pressure, so pressure is 1 atmosphere. Okay, so we've got excess acetic acid reacting. This is baking soda and vinegar is what this is. This is vinegar baking soda. So excess acetic acid, we have 28 grams of sodium bicarbonate. We want to know how much CO2 we're going to get. So it's grams to moles to liters, but if we're not standard, a quicker, easier way to do it's PV equals nRT. So we'll go grams to moles, stop, and then convert. So if we look here, grams to moles sodium bicarbonate to moles carbon dioxide, stop. Use N moles of carbon dioxide, N is equal to. It's a third, basically. 28 divided by 84, that's a third. You can just take 3 times this, you get 24, carry it to 84. So we have a third of a mole. Now, use it into PV equals nRT. We know this is 273 plus 20 is 290. We can look up the value for R. Just make sure you use the one that's atmospheres. I forget what table that's on, but you should say right here where it is. Pressure is 1 atmosphere. N we've got is a third. We're looking for V. Okay, so 1 atmosphere here, we're looking for V, 1/3 for N. The number that you use for R, if this is atmospheres, that's this number. 0.0821 liters times atmosphere divided by mole times Kelvin. Okay, that little table is on page, I forget. Let me see if I can find it real quick. I'll give it 20 seconds. Okay, page 454. Okay, I'll put that up here. R. Whoops. Look that up. Don't just write this down. No, surefire way to make sure you don't know anything. Just write it down. Just don't pay any attention. R, page 454. We looked at that. It was in the weekly notes. It's in the flip chart notes. That little table. Okay? If it's atmospheres in this unit, that is the number. Now, you got to solve for V, so it's a third times this, divided by 1. All the units cancel. Atmospheres is on the bottom. It cancels. Kelvin cancels. Mole cancels. There should be a mole written in here, and there's not. It cancels. V comes out 7.9 liters. Let's go to the next one. 46. Explain, when fluorine gas combines with water vapor, the following reaction occurs. Fluorine plus water gives you oxygen and hydrogen fluoride gas. If it starts with 2 liters of fluorine, how many liters of water vapor react? And how many liters of hydrogen and oxygen and hydrogen fluoride? So you have 3 calculations. You can shorten this up though, because you don't have to do it every time. Look, this is 2 to 2. So the liters should be 2 to 2, 2 to 1, and 4. I mean, these numbers are the liters as long as all the pressures and temperatures are the same. So 2 is to 2, 2 is to 2. 2 is to 1, 2 is to 4, 2 is to 1, 2 is to 4. I mean, you can figure it out with the parentheses, but I mean, that one's so evident that there's no reason to. Okay, if you can't figure that out, you don't understand, I'll work each one of them out for you. No problem. 47. Is the volume of a gas directly or inversely proportional to the number of moles at a constant temperature and pressure? Explain. Okay, if you use PV equals nRT, the ideal gas law, V is proportional to N. It's a direct proportion. Basically, if you put twice as many molecules in a balloon, it's going to take twice the volume up. 10 times the number of molecules in a balloon, because it take 10 times the volume, as long as you don't change the pressure or temperature. Okay, so that's going to be a direct proportion. 48. Okay. Says 1 mole of a gas occupies 22.4 liters at STP. Doesn't matter what the gas is, they're all going to do the same thing. Calculate the temperature and pressure conditions needed to fit 2 moles of a gas into a volume of 22.4 liters. So we're not going to put 1 mole there, we're going to put 2, which should double the pressure. We're going to keep R the same. We're going to double N, we're going to keep V the same, and T's going to stay the same. Look, if T's going to stay the same, we run into a little problem with that. If this stays the same, this stays the same, this stays the same, this stays the same, and we double this, this has to be doubled. It's the only mathematical possibility left. So if we're going to double the pressure, or we can cut the temperature in half. That's the other way to do it. Okay? We could cut the temperature in half on Kelvin scale. And that would keep the pressure the same. So there's 2 possibilities. There's actually an infinite number of possibilities. Because we could increase the pressure and lower the temperature, both, in any combination until we get there. You'd always have to keep the temperature more than half in Kelvin and keep the pressure less than 2 in Kelvin, but any combination will work on that. Not any combination, there are an infinite number of combinations that will work. Okay, 49. Ethene gas reacts with oxygen to form carbon dioxide and water. Write a balanced chemical equation. And then find the mole ratios. C2H4, O2. Or sorry, C2H4 plus O2 gives you carbon dioxide and water. Once you do that, you have to have 1 times 2 is 2 carbons, so that has to be a 2 in front. You got oxygen in too many places, so save it for later. 1 times 4 is 4 hydrogens, so this has to be 2 times 1 is 4. Now it's time for the oxygen. 2 oxygen here, 2 times 4 is 4, 4 and 2 is 6. That's to be 3 O2 to make that work. The mole ratios, that's what they are. You just balance in the chemical equation. Okay. Lab Friday.